Hello, everyone, and welcome to the broadcast. I'm newtmechanist, and today we're continuing our game development journey here. Before we get too far into it, though, I do want to check in with the kiddies who are mostly MIA. We do have... I can't tell if that is Mason or Sherbet in the play area. Could be Sherbet. He's got the white splotch that extends from leg all across shoulder there. And then, of course, Ember on the desk side. She is very alert. But today, we are getting back into things. Last time, we got our performance values up quite a bit. Here is 3 to the 6th yarn balls being created at once, which will cause it to spike wildly for a moment there. So 3 to the 6th, still very expensive for what it does. But we're still getting frames per second at 3 to the 6th being created at once with that. If we cull it down to like 3 to the 5th, we should get better results. Yeah. And it's not really a matter of how many things exist at this state, it's how quickly they're popping in and out of existence. We do have some numbers we can tune further to see if we can improve that, but I feel like our next target is actually going to be something different at that point. So a couple things we'll do. Go into standard inventory. We're going to pop up at the top here, and we're going to change that down to 3. Just so you can see things a little bit more easily when we're testing them. But we can do fun things like put moves for a bit, then pops into 3. It pops into 3 and spirals. Moves for a bit, orbiting inward along that line that it's going, then pops into 3 and spirals. Gate, remove that, remove the spiral, just fires in a line, trying to spiral in on the point that it's orbiting outward. So when we do this, if you look, the ball just kind of like wibbles in a circle as it goes. It is trying to orbit a point that is moving away from the center of the screen. So it makes it look like the ball is like, or like doing a, there were a couple of like contra weapons and whatnot that had kind of a spiral pattern. They're wildly hard to use. Comparatively. Hey there, Tass. And James. I see James joined us earlier. So we got a lot going here. The next thing we want to do is change up how we are reacting to collisions, because currently, when a collision happens, when I collide with something, I tell the entity manager to get rid of the something, which is why the player object vanished there. Yeah, we don't want that. So instead, we are going to be expanding upon the interactions concept. Last couple times ago, or maybe it was last time, I don't recall. Actually, I think it was a couple times ago here. We made a lifespan here. And what it will do is, if the interval passes, it will remove the entity. Now, what I may actually do is come up with a different pattern for doing this, so it doesn't just make the entity immediately pop. There may be some other things that I want to do. to make it clear to the entity that it is make it clear to the world that it is going away, about to go away kind of thing. Because there are some aspects of it that we could stop using right away. But then we'd need to make sure that the entity is properly cleaned up. So for now, this will do. This is a absolute shutdown that is going to happen. But these are over time. These go through every tick. So a timer lifespan or a time interaction here gets a how often it fires and how long it's been since it last fired kind of thing. What anything does with the accumulated delta is up to it. What it does when the interval fires is going to be up to it. Most things are going to set the accumulated delta to 0, but there might be other interactions that stuff like, hey, once it's fired once, treat it differently. Once it's fired twice, treat it differently. We'll see. We'll see. But, thinking about it, just real quickly, we are going to say... We'll get the basic one in there, and that's that... let's do 0. The basic one is once it fires, it resets its clock. You can do minus equals interval there, but it can get a little twitchy as far as how frequently it's firing. This would be in sub-seconds if we do minus equal, so you may never notice. But it could get a little off kilter, like it won't be happening equally. Or I talk about it. Yeah, there we go. So this tries to keep it at the same interval because the delta is limited by how frequently physics is ticking. If it doesn't tick often enough, then there will be overlaps. There will be periods when the amount of time that is passed is a little greater than the interval, so it will always be a little slower each time. You'll lose a bit each time. In this case, it might fire a little sooner than the prior one did, but it's still closer to once each interval by doing this. With movement, we don't need to worry as much because movement can be like time sliced down. Hello, Sherbet. But let's see. Okay. Got all of them. I have to check something just real quickly here. Just a minute. Had to do a quick head count. Okay. So we have these fire every so often. There's more we want to do with these. There are more variants that we want to do with timer interactions. Right now, what it's there for is to make them go away after a short while. Our network's being a bit flaky today. So the next one that we want to start working with are the collision types. Needs to make sure we get some terminology in here, because with a timer interaction, so timer interaction, what we have is this is your entity, this is how long has passed. So this is the one you're acting on. Collision interactions are a little different, is that there is a source and a target entity. So I think we can do it that way. So it would be entity, source entity. So when a collision happens, we are going to call into it to each one in sequence, and we're going to say source entity. This one collided with this one, like ran into. This is there. So in the case of, say, like a bullet runs into one of the blobs. So the yarn ball collides with a blob. There isn't automatically a reciprocal collision. There can be. We could have such a scenario, but right now we don't. It's one way. There may be a reason for us to do both, because it gives us a second chance to catch a collision happening, but this way we have a very constrained I act upon you kind of structure. So this one runs into this one. So this makes the structure a little wonky. I think we need a separate method for passing the message. Because initially there is no interaction message. So I think the first thing we do is we interact and we get a source and target. Then it's going to do a thing, and it will pass along any relevant messages. We're keeping booleans in there to say, was it handled? You know, is it done? Because if it's completely done, then we should be set. Let's say take damage. In general, I'm expecting only one kind of thing will assume take damage. We could have it where each instance of take damage is going to is only going to be consumed by like a can take damage kind of collision manager, or a health collision handler. So the yarn ball hits a blob. The yarn ball has a collision handler here, or a collision interaction that says, I will send a message that is of type damage to you with, 2 points or something like that. The blob will have a collision interaction on the receiving side that will see that message and will react to it accordingly. It will say, oh, okay, I have this interaction that when it gets this message, it processes it, it takes that damage number and uh, subtracts that from its health, reacts accordingly. Maybe it removes itself. But then it calls back, I dealt with this message. This message is gone now. It is possible that we let it run all the way through instead. But one other possibility is to just say, if it happens once, that triggers, you got a collision, don't process any other collisions. Something reacted to you bumping into it. If a collision happens in the physics world and nothing happened as a result of that collision, the thing you bumped into did not react to any of your messages at all, then that's not going to count as a real collision. We will continue to process collisions on that particular entity. But if any part of the collision was handled, then that means there was some sort of interaction. Something, you hit a wall, you hit an enemy, you exploded, something like that occurred. We don't need anything else to act as if it had touched that. Even that is questionable. No. We're going to start with it that way. Yeah, we're going to run the message through the whole queue. We're going to run it through every single thing that gets the collision. We're going to run it through the whole thing, and it's up to the entity itself whether it will ignore a particular interaction or not. We might have to have like a ignore collisions or something like that that gets triggered as soon as one gets processed. We call this. So the core one is interact, and that is, here is the source, here is the target, do what you need to do. Yeah, Tess, I was thinking, as I was talking through that, I was thinking, well, but what about explosions? The explosion itself is going to interact with as many things as possible. And even with that explosion going off, there's nothing to say that there isn't some other force that will act upon those entities. So I think each interaction type is going to decide whether it will halt interacting or not. It could cause some performance issues if we don't do this cleanly, but we'll see. Okay, so the first one, interact, is going to have this, source and target. The second one is going to take an interaction message, and that's, something is being done to you. Don't like that function name. It's going to be an interaction message. So this is called from outside of it. So the entity itself is going to be running through its collection of interactions. And it's going to call interact on them each time. It's going to say, me, and this is the one I ran into. So if we look at entity, when it collides, this is the target. So it's going to iterate over its I send messages at you interactions, and it's going to ping each one of them in sequence and say, okay, what do you do? What do you do? What do you do? Then on the receiving entity side, each time that happens, well, what's actually going to go down is it's going to call that, and it's going to ping that individual entity each time. So for it, each collision is going to go in and say, here's your source. It is going to call something on the entity. So we're going to... we'll just do interact. I do. So what we're trying to do here is get kind of a call and a light response. This is a collision. This is going to be primary interaction. In theory, there could be other things, but the way this game works, run into is kind of the interaction. From every direction, there isn't a, pull lever. I'm trying to decide how much of this handle collision is on the entity side, and how much of it should actually be on the entity manager side. And I kind of want it to be over on the entity side. It's the terminology that I'm considering here. We get a call to interact. So we say interaction message. Here. So the thought is, if I get a collision, I'm going to iterate over yeah. That sounds about right, Tass. Okay, so collision manager tells an entity, you collided with this thing. Entity is going to go through each of its outgoing interactions and say, all right, do your thing, essentially. Those interactions are most likely, but not necessarily, going to call interact on the target entity and send a message to it. That entity will then iterate over its receiving interactions. So in this case, the default outgoing interaction is cause damage, and the default incoming one is, take damage. Almost everything will have this, but there are other possibilities. There might be projectiles that cease to cause damage. So maybe a type of bullet that after it ends, it puts something on the ground that its interaction is to shove things. It doesn't cause damage, it applies a force to them. Yeah. It could just be like slows enemy down. It applies some sort of temporary debuff. Oh man. Debuffs are going to have to be something I'm going to have to put in here somewhere too. It would have to be handled in the moving process. Oh. There will have to be some extra wrangling once we get to things like applied effects. Because, for example, if we say there's a repulsion field on the board, and I do see a follow from Rescorn over on Twitch. Thank you, Rescorn. If there is a repulsion field on the board, that repulsion field is applying a particular force to everything near it. It is not... The entity itself has no idea what's going on with that. Like, it's not looking at that and saying, oh, there's a repulsion bubble near me, I need to move away from it. That bubble is saying, I'm going to give you a push of about this hard. So when the entity is applying its movement, that is a temporary vector change to it. Oof. Anyhow, we'll burn that bridge when we cross it. For now, this is all the outgoing ones send. This is all the incoming ones receive. Which means an entity needs fence, our base behaviors and gates. Oh, hey there, Alkaline. Welcome back. Okay. We need to figure this one out. So, one of the tricky aspects here is we want to be really careful with trying to do overlapping areas. One of the tricks here, James, is to remember the collision zone for an entity is external to it. That is, it is a circle that exists in a collision area somewhere else. It has no control over it. It just calls out, hey, I'm at this position now. And that external collision manager is handling it. So it can't... it doesn't have that opportunity, I should say. But your general idea of we could have a pool of what amounts to temporary behaviors that get processed like at some point. We'd have to decide whether they are prior to movement or after movement kind of thing. Such that, let's say I'm in a... It'd probably be after movement, actually. Let's say after movement. So I get to the end of it and say, okay, I have a buff on that makes me move faster. A temporary effect that makes me move faster. So I have when I apply this, it says, okay, your proposed movement is now 10% amplified. Whatever motion you were going through is now 10%, whatever vector you had is 10% further. Another one might say, okay, apply force from this thing, or apply this force. And all it does is add a vector to your movement. So if it was saying, okay, Um, that's also tricky. We need to come up with some sort of delta for it. Like I said, we'll get there. We'll get there. But that could be like a post behaviors. Most buffs and debuffs could just be behaviors because they will affect how the entity does things. Okay. Public interaction. It's not a... Why do we have a master interaction? We don't have a master interaction. Uh-oh. Well, we're not coding in VB, so... How you doing today, Alkaline? So the base one is always going to be there. We are going to need a collision interaction group as a result of this. And hello, Kitco. Welcome. So just like with behaviors, we have one that is always present. We're always going to apply the interaction to this. So take damage is always almost certainly going to be here. With bullets, it's a little different because we can get different stages to it. We could have the first one say, if you run into something, apply, do nothing. Like, by default, it does nothing. Then, how to get this in properly? So by default, it does no damage. It has no deal damage interaction. Then, after a gate fires, the next set of behaviors are going to happen. What I'm kind of thinking here is like a kind of a rocket launch kind of thing, where the rocket initially fires out and then there is a burst and it moves faster kind of thing. In any event, so there is a subsequent change. If it strikes during the first period, it does very little. But if it strikes during the second period, it does very much, kind of thing. So a projectile that you want to land its hit after the first stage. We could have that, but these gates change things. I don't want behavior gates to be the same, or as necessarily as interaction gates, but for simplicity they may need to be. For user simplicity, they may need to be. Put another way, I think they need to be. Need to rename these entirely because they're not We're not interacting in the same way. But we'll deal with it. Okay. We might just make this... I don't know, we need a base one. Means we need a base group. Yeah. Okay, so we're going to make some interaction groups with these with the same pattern as behaviors. So there will be collision interaction group and there will be time interaction group. Same with behavior group. And the reason is so that we can kind of mush them together. Reconstruct them, you know? A lot of this is stream of consciousness, folks. If you have questions or anything like that, feel free to fire them along. I can stop and chat. But otherwise, what you're getting treated to is me thinking out loud constantly. This is actually one of the places we were at earlier. Before our C# rewrite. We had these incoming outgoing concepts. Hey there, Jack. Welcome. Doing well today. We're doing well. We are working on collision handling here. We get the collisions, we want to make them more robust. So same pattern as with gates and behaviors. Being a moderator is something that happens over a great period of time and with a great deal of trust. So, you know, maybe sometime in the distant future there, Jack. I'm going to have to look at how I reconstruct these a moment. Standard inventory. Programming languages are one of those things that you kind of pick up. Happily, they come along more smoothly than regular languages, than spoken languages, I should say. Process behaviors, okay. Okay, we aren't breaking up the groups at this point. What is this project about? Here, let me show you where we are, assuming I haven't broken something. We're making a Vampire Survivors style game. Actual narrative of the game isn't set in stone, but it is based off of essentially character lore. It's something that has kind of grown over time. But it's players in the middle of the screen. They will be able to move around. I haven't just put that in yet. Camera follows the player. Oh, well done. Gas fired first there. Thank you. I'm using Godot 4. I'm coding the structure of the game in C#. It's not the whole engine, but it is. There is substantial logic that happens here. As in, the rendering is non-standard Godot, the collision is non-standard Godot. The reason that it needs to be non-standard Godot is because I need to be able to do stuff like this. So I am currently generating, when the yarn balls fire, we can let it go over 8,000, and it will drop a bit of performance. But each yarn ball, once a second, comes out in a random direction. After 3 seconds, it bursts into... I keep having to think up what this number is. 729 yarn balls? Alright, we're getting a bit of degradation there. Well, now I'm concerned. Something is different. That's a lot of yarn, yes, Kitco. Quite a bit. Alright, just spam it. Tweaking a variable. Oh, no. Trying to tune a number here. 5th to the 6th to the 7th. Let's make it worse. So we're creating 2,500 yarn balls per second here, which is way too many. And we could space this kind of thing out a little bit and reduce the strain. I haven't yet recreated burst behavior as far as containing how many things, you know. I don't think we need that few. Just a couple more variations. That's not frequently, Kitco. We don't want you to frequently, easily hit this level. We want you to be able to hit this level. So one of the inspirations for how we're setting this up is a game called Noida. You may or may not have seen it. Shows up in streams a lot. It's a good rage game for a lot of folks. The construction of the weapons is meant to go down that road, where the sequence of the icons and which ones is going to change how your weapon behaves. We want it to be possible to get to what I usually refer to as a calamity case. And that's... the game can hardly handle it. When I made my Noida mod, and when we played it on stream a lot, we had the joke of the quality of the weapon was determined by whether you were operating in frames per second or seconds per frame. And you had achieved peak performance if you hit minutes per frame. We caused ridiculous blooms of projectiles and similar. And the way this is set up currently, so this is 81 projectiles per second, each of them having a distinctive motion pattern here. Out, spiral in. So this is projectiles moving out in a random direction, splitting into 81 projectiles, spiraling out along the path of the random direction, and then spiraling in along the path of the spiral out. Then we add another burst here. And so that was the sequence that I was telling you there. Random direction, spiral out, spiral in. So the spiral out moves away from the player in some direction. So it's like an expanding cone. Then the spiral in is following the arc around that expanding cone, which is going to make it kind of do little circles. If instead I switch it to spiral in, spiral out, you see how we're getting a different arc forming here. Now it tries to follow that tight little circle following that random direction, and then along that path, it's trying to spin out further and further. But it's now fighting against that spiral in a lot more. Because the spiral in wants to pull it back towards the point that is the ball fall, or where the yarn ball is going. And then we can do things like we gate it. So here's it doing the tight spiral in, and then after 3 seconds, it adds the spiral out. So this is the game we're making. Lots and lots of extra logic going on. These aren't like the end state units that we've got, but okay. I think that's operating well enough there. Then let's just double check our Calamity Edge here. works. Past 15,000 is closer to our seconds per frame rate one. So we're just under 15,000 and we're still frames per second. It's 4, but it is greater than 1. So now we're going to add another multiply by 3. So this should spike us up towards 20,000. And 3 to the 7th is how many yarn balls we're creating at once. So you see how the frames per second number is at 1 right now. It's not 1. It's less than. The display rounds up so that the number doesn't stretch across the screen. I could just truncate the number, but it gets fiddly. So then we're going to drop back down. I am not pre-sizing my arrays. We could just have... Right now they're in flexible things like queues and lists and hash sets. But we could use kind of prefabricated ones. We'll have to see. Because I know pre-creating the shapes doesn't matter. There is a wind-up period as far as the collision shapes are concerned. It's gonna take a while at this tick rate for it to start to fall off. Yes, we do have some sort of object pooling. So there are 2 points at which the pooling is really a thing. So there's drawing and then there's collision. Every one of the collision objects that exists, so the hitbox of the yarn, the hitbox of the ball, those are all controlled by one entity, which has it's kind of a pool of pools. So each hitbox exists in one collision zone, which is a... Oh, I'm thinking about it. We might have issue there. Might be an issue there. Okay, let me... So... Standard Collision Manager. Let me just check this. Each type has shape indices. And then each type has collision. Okay. That would make some sense, Parakeet. So this queue is pre-allocated. Way for us to set that. That's a good point, Parakeet. That's a good point. So there can never be more shapes than max entities. And we had a number of them here. This is the player case. Sorry, what I'm trying to look at here is in the collision handlers, can I get some nice pre-allocation in there? And we should be able to. I have my memory has been lost as far as all the changes we made to the collision area last time. I'm trying to parse this here. Okay, areas per type. It's what we want for each collision area list here. Set that. I thought we set that up near the top. Yeah, okay. Have a yeah, okay. Sir. This guy has come for chin scratches, which means the mouse is imperiled. Yeah, I see you. Yeah, cam over, so so that's kind of the back half of him. 2/3. The front is draped across the little pillow there, which puts his forepaws and face right by my mouse. And if he doesn't get the attention he wants, he's going to slam his head and paws on that mouse. With malice aforethought, he knows what happens. You know, not the technical particulars, but he knows it will do something that gets my attention if he messes with that mouse. Okay, each list of collision areas also need the entity shapes dictionaries set up. These is fine. Entity shapes should have that. Should have areas per type. Okay. Did I break it? Okay, we are pre-allocating space for all of them now. Still slower than I'd like, but okay. We are going to get. I don't think this is bad to do. I think this is still a good idea to do, because we know how many areas will be in each list of collision areas for that type. So we know that there will be this many of them in the enemy category list. So we won't be messing with that list. Okay, now if we go into... Let's go into entities as well. Standard entity manager. You know what? It's gratuitous. We're eating memory that we shouldn't. Might be a good thing to check too. A to the 6, so this should start us towards a problem threshold. Okay. Physics common. This one is trickier for me because this is pretty variable. We could reasonably put that as a smaller number, or a bigger number, I should say. But what if we change that? into the problem case. Anywhere that we have, because all the rendering should be pre-allocated. By its nature, the rendering is pre-allocated. But maybe there's a spot where we can tune that a little bit. Well, let's. We are turning a lot of dials at once. Let's stick to one dial here for a little bit. The same. It's at right about 10,000. We're dropping that by half each time. Still at about 10,000 shapes being processed. Hey there, Vampire. We're doing well. We're still looking at some performance improvement we can do. Name of the game with a lot of the development that I'm doing is performance improvement. Because we want to have as many things going on the screen as possible without it getting slow. Because if I keep the threshold very, very, very high, it means that the game will perform even if the player finds something crazy to do. And by that, even if, it's as much a matter of when. We're at about like 1.5 seconds per frame. It's slowly ticking up here. There we go. But we definitely know that our safe zone is under 8,000, which is still fantastic. Oh. Guy has crawled onto my lap and is demanding attention. How old are my cats? Okay. So Sky, the one I mentioned on my lap here, is... Oh, he's got to be going on like 10-ish, maybe? Ember is a few years old at this point. Sammy is a few years old. Mason and Sherbet are maybe 2 or 3-ish. I haven't kept careful track. I'd have to get their records to know precisely when. But Mason and Sherbet are definitely the youngest, then Sammy, then Ember, then Sky. Giving you guys something visual to look at while give Sky intensive ear scratches and what have you. What we have right here is random direction spiraling on that random direction, like tight to it, splitting into 3, and then after 3 seconds, split again. Each projectile splits again into 81 and spirals outward. So the movement gets crazy at the 3-second mark there. We pull the spiral in off. You'll see the burst and spiral a little more clearly. But like, for example, this is very plausible for us to have. A split in 3 and then split in 3. Absolutely, that's very likely to happen. Split in 3, split in 9, pretty plausible. Nine and then 9 again. I am going to have to figure out something to make it so that the splits can stack a little bit better. To make it a little bit clearer how they're splitting. Which means I might just have to gate every split. You know what? Oh, okay. What do we got? What do we got? Tell me of your errors, Godot. Instance overflow. Where is it? Mesh render. Mesh render. Mesh render is the chicanery we are doing here in order to draw to the screen very smoothly. Everything that you're seeing drawn on the screen is one entity with shaders associated. All right, we are priming this somewhere. There we go. This is going to be a problem. That's... Why can I not? Public constant int. Oh. As it's a public constant, I can just do that. Run it here. I want to run it on the Godot side because that will catch Godot errors. C# side catches the C# errors better. The Godot side catches the Godot errors better. Shocking, I know. Seven. This should get us to an error state. Or a choke state here. Maximum busy. Okay, we're still alright. Let's drop it back down into sanity territory. Again. I like this pattern. This is an odd side effect of the way this works. This is an inward spiral. I'm using a well, it's the wrong text here. That should be spiral in, but the spiral in tries to tighten its radius. But that is based on its distance from its target. And when a spiral is following prior movement, when there's already movement happening by the time the spiral starts calculating, the center of the spiral is moved in accordance with that prior movement. So because by default, the yarn ball is moving linearly in a random direction at about 1 unit per second, about the height of the little catbot in the center per second. That means the center of that spiral is moving like that. So instead of getting an actually tightening spiral, we get these little loop-de-loops going on, which looks neat. Like, I'm actually going to use that somewhere. Any errors happening? No? Alright, let's escalate. More yarn. So this does make things more chaotic, because the direction is splitting further. When the random motion is created, that's a single vector. When it splits, the direction that it is considered to be going into is kind of spread across. So if there's 3, the 90-degree arc that we come up with, the space of the left and right ones are effectively rotated. And that happens on each subsequent split. So it's possible, like we can see some of the little yarn ones are drifting back towards center. We get this sort of like central radius going on around the catbot. Those are the ones that have almost turned back in towards the center as a result of the splits. Find my cursor. All right, to the 6th is going to get us over 8,000 here. Should be under or around 15. here. Still not getting any errors, so that's good. Physics time is non-trivial, but we have a whole lot of frame time. Like 30-some milliseconds is not great, but that's not enough. But the frame time of 200 is definitely going to cull our frames per second pretty hard. But we should, like, if it were just physics choking it, we would be getting a lot higher frames per second. I haven't located our orphan node yet. All right. Like, we gotta try on the Visual Studio side here. To gate it, just need to do that. Was that profile? We used it previously. I'm trying to figure out where it was. Should be. VS Code was kind of limited in what I could deal with here. Not what I'm looking for here. So there's the crossover call, which helps us do nothing at all there. No, I don't want... 4% of it at any given time is in mesh render on it. We go across the whole area. It's still mesh render. So is there... There's something more we can do here to clean that up. So we don't need them for each texture, but I wonder if... Alright, this is... I'm going to test this, and it will be unpleasant. Never be more than max entities things to show. So this is us sorting it. Gonna temporarily cull that. It's gonna look terrible while this is happening, by the way, so... Prepare for flickering. Within limits. We handle it a lot better this way. Okay, so physics processing ticks. Let's reset at least one of these things here. Just make sure, because like I said, I'm turning a whole bunch of dials at once here, and that's not really good practice. Okay, not a tangible difference with the physics solving iterations. That is not a bad thing, a dial to turn, but I don't know that it's one we need to turn yet. Okay, so it's not sorting of the things. So rendering has become a bottleneck with this. let's go into our standard inventory. We go into where we instantiate the stuff. We are going to remove the blob from the list. This limits us down to one thing that will exist, and it gives us an opportunity to control it. So now we go to our standard catalog, and we're going to hop into load entities. And we are going to remove its move random direction. Like stickers that have the sort of scratch off ticket coating on them. Okay, nothing moves. This is not the same test because there's extra layers to it. But it only costs us, say, like 3 or 4 frames per second at calamity case level if they're not moving. So the motion is not too big a deal. What else? Okay. If the mesh renderer, if we just use a dummy renderer, that should work. We'd have to come up with a scene for that, though. Yeah. Extends a render is a node 2D. Okay. Making sure I've got this right. Scene 2D, it'll just be render. Render is that. Attach a script. It's render.cs. We load that. It does nothing. Okay. And then in our default startup resources, instead of loading the mesh renderer, they're going to temporarily load the default renderer. Nothing should draw, by the way. That should not be. Not attaching the script. Okay, so what I'm running into here is that this is attaching to a scene just fine, mesh renderer. But renderer is not. Oh. Because it can't be an abstract. Save. Build. There, stuck that time. Okay, things exist. You can see that the number is counting, but the default rendering entity does nothing. This is one of the reasons that I've taken so much time to get my structure set up. This is valid to do as far as testing. There is no drawing happening. There is no interaction with space aside from what Godot does to node tree in general. Okay, no drawing. There is collision happening, though. There is movement processing happening, though. We get an extra maybe 1,000 if we don't draw. Okay. Go to our default startup here, and we're going to put the mesh renderer back. Yep, Parakeet, the mesh renderer solution is super cheap for what it does. It is a multi-mesh, and then this shader right here. That's how all of the drawing happens. I'm quite pleased with that. Okay. We should do the same thing with collision, then. So the collision manager is currently an abstract. It is no longer an abstract because I want to be able to use it. So collision manager is a node 2D. Script to you is collision manager. Didn't like that because I have to rebuild the C# project on the Godot side so that it can see it. back. We are connected. We go to our default startup resource. See, all this madness was totally worth doing. Okay, Collision Manager has been overridden with one that doesn't do anything. Like, it does nothing at all. Okay, it gets a little expensive for us to just be processing 20,000 some things. But so it's 20,000 things being created at 5, let's say 2,500 things per second at most is being created. Collision is our weak spot. Collision is our weak spot. So we're going to make an interim commit here, and then we're going into the weeds. Because, again, I want Calamity Case to be a viable thing. I want it to be something that if you achieve that, then worst case, I make the game ramp up to try to slow you down, you know? Not to punish you, but to make it so that there's stuff that can stand against the offense to some extent, you know? That and, like, fiddly secret things are things that I want to tie into progression. That is, if you get destructive enough that creatures can't even approach the screen without being annihilated, then the game should react. You know, the enemies escalate if you escalate. So again, here's with real collision. I hope the lack of hand movement on this part of my model does not impede your ability to perceive my air quotes. Three to the 7th with collision immediately plummets. Okay. Alternate collision schemas. Let's... Okay, interim commit. Interim commit. That... Yeah, I think there's extra optimization we're going to have to do here. Part of the problem is, I think, like you're saying, grouping. Yeah, okay. But let's get more of these in here. Finding all these spots where I preload collections to make sure that they are... we pre-sized the buffers and pools. What's going on there? Something as I'm doing this, something may have gone wrong in this. Okay. Not clear why it says this. I mean, it doesn't need the shader anymore, so. Okay. Okay, so some core considerations of how we're doing collision are drawn into question here. For one, I'm probably going to change standard collision manager to like area collision manager here. Because again, a core principle has been put into question with this. Let me shape isn't interacted with directly. Doesn't interact, or the entity doesn't interact with its shape directly. It's indirect. We get the entity and we subscribe to its events, but it doesn't know about us. Okay. This is good. So what do we do? Yeah, we'll move all of this stuff into like area shape or something like that. Oh man. So the quandary we face, again, is that the fundamental way that we're going about collision handling here is tricky. Let's do an edge case test here. This goes against the optimization that we're dealing with, but there we go. Max shapes 1. We still should be in safe territory. There are a whole lot of collision areas going on right now. Okay, it slows down way faster if we've got one. It is. It's just a... So we're making the shapes on physics server, and we're attaching them to areas that are Godot areas, like they're part of the tree. And the areas drive the collision. We could do that directly through physics server. It's just... there are... I've had great difficulty getting the areas rigged up properly on just the physics server. But the shapes, it's quote, straightforward. But I think this is part of the problem, is all of these shapes overlap. There's no world optimization. There's no like quad tree optimization available, I think. Yep, each of them has its same mask. So the bullets can only see the enemies can only see the player as far as collision. No bullet-to-bullet interaction. Or at least it's supposed to be. Let me verify. Player interacts with nothing. Bullets are bullets, they collide with enemies. These are enemies, they collide with the player. Do here. Wonder if we could do a ray trace in this scenario where we're just checking against the shape. Let's our next test is going to be to go in and remove any sort of collision check. Like, it is not doing any sort of looking. There's going to be no collision at all. But first, we're going to take a quick break, and then we'll be right back. Okay. Right about on time. All right. we're gonna run a test with no collisions happening at all, but they are. That's interesting. Oh, okay. No, I did it the other way around. When you default create an area, it wants to collide with everything. Okay, doesn't change. Giving it a few seconds to let everything fall off here. Yeah. No change on that. All right. Okay. Second check. We fiddled with the masking. Now let's just turn off their monitoring entirely. 6 will create the problem case. Okay. So it's potentially just messing with the shapes at all that's running into a problem. All right, all right. I think we'd still need the shapes in the physics world, though, is the problem. Like, they'd still need to be part of areas, and they still need to be moving around. And just messing with the shapes seems to be enough. Huh. Oh, well. This is when it should be. This shouldn't be here. Capture here. monitoring and monitorable are true at that moment. It shouldn't be until this moment that it matters, because it's not part of the physics processing loop until that occurs. So by doing this, by creating a ray cast here, each time we move, what we would still need is something that amounts to the shapes of the entity, and then some way to get it. I mean, it needs to have something to hit, is what I'm referring to. That's potentially already a problem, because we can see I go in and this won't do anything. This should never get called. So we are just messing with shapes now. We get further. But, we get to about 12,000. But we're still messing with shapes. Way up, max shapes 1. Every area has just one shape. There is no collision going on. This will get us over 8,000. And we hit the problem sooner. Okay, just wanted to verify. Need... We potentially have to rewrite this thing. Or at least get a version of it that is back where we are just creating the shapes relevant to the different areas. Do we? We still need to have movement for that. And the physics server still needs to have the shapes attached to an area. So we still need all of this, but just removing the collision checks, just having shapes in the world being edited is enough to trip this problem. The ray movement, I think, is still a good idea. So what if... We're going to see how much we can tune here. I'm looking at how much we can minimize it because we could still be able to combine them. Keep the shapes simple. Still plummets at 15,000. I mean, it's in better shape at 7 frames a second. As I'd like to be able to say that we could avoid multiplicative split like that, but I don't know that we really can. This is all fundamentally not having a big impact. Enough for that, but... So I'm adding a bunch of gates here. We're going to say weight 3 split. Weight 3 split. Split. So we're creating them much more slowly here. We're going to need to give it more lifespan for this to work. Span elsewhere, but we can. We'll let him live way longer here. that. We're going to take lifespan and use it here. We get a copy from the catalog. We adjust its interval, and then we load that up. So it's still timer lifespan. It's still that kind, but we're setting its interval on the fly here. We could do that with anything. 3 at a time, wait 3, 3 at a time, wait 3, 3 at a time, 3, 3 at a time, wait 3, 3 at a time, 3 at a time. So 12 seconds of their lifespan is consumed getting to this point. Same problem. It's just a number of shapes. Sheer number of shapes that we're interacting with. I mean, we're holding faster if we do it this way. We aren't creating so many simultaneously. If we always say that a split is gated, that will help. Because it means that we're never firing all that many of them at once. It has to split into 3 and begin a new chain of movement, kind of thing. It helps. And it limits it. So let's go back to our standard collision manager here. But how can we optimize here? So, basic node 2D behavior. Let's look at it from the Godot side. Child. Area 2D. What else do we have with it? It's a 2D object, so it has a bunch of physics stuff and audio stuff. It's layers and masks. There's nothing really that we can add to that that's going to matter. if I wonder if there's a way to flatten shapes, you know? Is there something we could do to say, like, okay, get all of the shapes and then mush them? Here. Get data. I don't think we're too far off from that ultimately, Lunar. Circles. Not using bodies. We might be able to create the area and work with it, but wiring up the collision events is a little flakier from Physics Server 2D. We might have to explore that inevitably here. Because, again, our current problem is the collision handling. We have got it back to where if we only have 8,000 things, then we're going pretty well. 10,000, little choppy. Get a little choppy at 10,000. Let's go to our entity manager and let's say we put it at just 10. Split into 9, wait, 3, split into 9, wait, 3, split into 9. It looks like 5, but there are there's some overlap being generated there. So we get some hitches at 10,000. But in our current state, we're getting some decent performance here. But it's at that final moment where we get the final 9 split that it really bogs down. And to some extent, it's just there's a huge amount of processing going on during the behavior step when we do this. Because we have to instantiate all of these objects in the subsequent physics step. Or attempt to, I should say. Let's run this in the Godot side. I do want to see if we're getting any errors at that point. Seven. Space them a little bit each time. Nothing that actually stops me from lengthening this for the purposes of testing, but I feel like 10 is a reasonable cap. So again, this is to the 5th. It can bog down. Getting any errors? Not on the Godot side. We've got to we've got to get like profiling going on here to figure out where in our code we're actually getting that choke point. And I thought there was something here. While we were running, that we were able to halt it and see what we wanted here. So this state should generally be fine. We're going to get higher than we have in prior tests because we're letting this live for 20 seconds. Instead of 3 to 10, you know. But it climbs slower because it takes time for them to hit their final splits, you know. So we're going to swap this in. We're going to immediately be emitting 9. So we should breach 10,000 pretty quick here. As far as rendering is concerned, why we found that this wasn't a big deal is that we have essentially a big surface here, and that surface already knows that there can be 20,000 things on it. It is already ready for that to happen. It knows that those 20,000 things are about this big, that kind of stuff. Right now, there's going to have to be some extra math in the shader to account for sprites that are bigger than others, essentially. But I might just have all sprite sheets be uniform in size and centered. So one thing this shows us is that we can have really big split events, but we have to contain them based on gating here. Again, 3 to the 6th objects being created simultaneously here. If we remove a gate, now we've got the first 2 splits happening earlier, so it's going to hammer us a little harder going forward here. Oh, I'm kind of stalled here because it is we're facing a very tangible increase here. Just for giggles, I'm going to change gate to 0. Gate weight 0 just says as soon as 1 frame passes, the gate opens. 3 gates split into 3 gates split into 3 gates split into 3 gates split into 3. So it looks very, very similar, but if you can see it, the outline on the yarn balls is a little thicker. That is because there is a teeny tiny bit of time that passes between each one being emitted. All right, there's the 5th. Now we're going to pop over to the 6th. It's about the same. It helps a great deal if there's a pause between splitting. Back down to the 5th, let it die off a bit. Yeah, it takes upwards of 20 seconds for the die off to occur here. Yep. The pause is 0 based on the code, but a minimum of I'd say it's like 33 thousandths of a second, or 1/60th of a second. The minimum of 1/60th of a second has to happen before the gate can pass. So essentially, the next physics tick. Here's to the 4th. This should drop us below 7,000 objects pretty steadily here. This is they always spiral. Then we're going to change it so they only spiral at the final burst. Which, again, is effectively immediately. There's my cursor. Easy to lose your cursor in this. Okay, so one thing we know is that gates have to be, that multipliers have to be gated. I think that's a truth that we have to have in here. One thing I may do is have a default split. I'm sorry, a default copy does not change the lifespan of the projectiles. So if I am just splitting a projectile, I'm creating 2 exact copies of it at that moment. So, I may be already just babbling here. Let me see a timer event. Again, folks, this is Stream of Consciousness. If you have anything you want to ask or comment on, feel free. Timer is duplicated. I'm going to try this for shaders for math is always, I mean, abusing the GPU, essentially. I may have to ping my doctor after all and look into a different kind of inhaler, because things like usually when I laugh, it's kind of a lower in the throat kind of thing, and any sort of interaction like that can make me cough. Which is kind of sad. Wibble. Okay, so even if they split, they do not live longer when I'm going to do this. Anything that has a lifespan, when it is duplicated, its lifespan as it is duplicated. So this is 3 to the 5th. They live for 20 seconds. And they spin because I think it's neat. I'm going to move one gate so that we can get to 3 to the 6th. 3 to the 6th normally creates the problem case. Okay, I think if we go this road, this is a hard constraint on the way that projectiles can be propagated. I don't plan on having too much stronger than something like a split into 5. And given this logic, a split into 5 will cost you a lot of lifespan. That is, there will be a big timer before the split into 5 fires. So we could do that. Well, that's not a split into 5. That's a split into like 700, but that's wait 9 seconds before that happens kind of thing. So if we wait 6 seconds, split into 3, and wait 3 more. We still have a lot of them being generated, like a whole lot. But if we look, we're at 3 frames a second with 16,000 entities on screen. And most of these entities would be running into enemies and dying early. Many of these entities would be running into enemies that soak multiple of them. Because not all of them are going to be able to pierce. Yeah, there's more optimization we can do, but the way that I've set the system up would allow us to swap it in as a module at a future time if this becomes too much of a burden for the system to handle. I'm gonna have to say this to myself a lot of times because it bothers me that it's not working, perfectly. But I feel like we have to declare good enough for now. Because, again, 15,000 objects, 3 frames a second, I'm kind of okay with that. Because this is Calamity Case. This is you're firing 700 some things at once. We can bake it into the way that these work to make it so that these are very, very expensive to use. A Noida split into 10. This is double that. If we say, oh, you have to wait 6 to 10 seconds for that to fire, well, that's a big trade-off. You have potentially massively increased your coverage, but it takes a while to happen. So after 10 seconds, these things detonate into a lot of extra projectiles. Let's say 6, just so you can see it sooner. But that's like a third of their lifespan before that happens. That's a ways out. And if it's not an on-impact effect, it may never happen. If they're right on top of you and they hit the yarn ball right next to you, it will never detonate. I think this is where making use of our system of I can just create all kinds of permutations of stuff to slap into the game. It's being cognizant that multipliers are grossly impactful. I wonder. If we... I still would like to find a way to squish these multiply by 3s. I might have to come up with a system for telling a behavior to merge, where it will go through and say like, okay, will you merge with any part of this? So that if within a given group. Yeah, you did, Lunar. It's something that we've been cycling back to of if within a given cluster, so within a given gate, we have multiple of these split into threes, can we find them and can we mush them together? It won't stop us if we have, you know, a split into two, then a gate, then a split into three. Because these are separate clusters. But if that changed from a split into three, so instead of multiplicative, it became additive, then we would just be getting 5 and 7 instead of, we'd be getting 35 projectiles instead of way more than that. But if instead we say, 1, all splits are gated, that does help prevent them from mushing together too much, but it then subsequently means that I don't have as many opportunities to combine them. So we need... Again, good enough. It's good enough. I think carrying the lifespan forward is an excellent thing here. I think that will do it. Let me see if we can really emphasize why that works. Load entities. We go down to the yarn ball. It doesn't live for 20 seconds. It lives for 10. So by default, let's follow this yarn ball here. "10 seconds, it makes it off screen. If after 6 seconds it splits into 3, we wouldn't use this for actual. And then 6 seconds, it splits into 3. Then 6 seconds, it splits into 3. Neither of these can happen. Hey there, McMuffin and company. I see that we have a raid of many people. Welcome to the channel. We are currently fretting over performance, and I am trying to convince myself that we have tweaked it enough that it won't explode on us. So we'll show this for a moment. And again, hello everybody. Welcome, Raiders. We'll show this for a moment. And since we've got a whole bunch of people in, we'll go over a bit of what the channel is about. So lately, I'm newtmechanist, and what I do lately is code this game. I think we're on stream 91, isn't it? Yeah, stream 91 of coding this. 2.5 to more hours per stream. We're using Godot 4, coding in C#. We started in Godot using entirely Godot infrastructure, and we've been tweaking performance ever since. Because we want to be able to do stuff like this. So we're going to hit Calamity Case in a moment here. Well, we might actually be able to hit Calamity Case. but most of the projectiles time out very quickly afterwards. So 3 to the 7th split. After 6 seconds, each yarn ball will split into over 2,000 yarn balls. So once we hit about, let's say, 16,000 yarn balls, we drop down to about 2 frames a second. Oh, wait. Okay, yeah, about 2 frames a second. We're actually still keeping frames per second. If instead I give it 3 seconds before the split happens, we're probably going to hit our 20,000 entity cap, and at that point we're going to hit seconds per frame. These are terminologies from back in the day when I did my Noida mod, where our best runs tended to culminate in a boss kill that we determined that the kill happened, but it was operating in minutes per frame. It sometimes took us upwards of 5 minutes to know that the game had not crashed yet, because we get a frame update. Even after 3 seconds, we're still holding pretty well. I mean, 2 frames per second. Ish. And that's with 7 split into 3s, and split into 3s are multiplicative. But because we have added logic that says it does not gain lifespan every time it splits, that the new projectile has the same duration that it has lived. I mean, there is, at least as far as pixel animation, there is a smoothness that you get with 60 physics frames. Like 30 physics frames has an impact more than I think 30 render frames. Okay. All right, let's let it cool off here. Oh, yeah, I misread that there, Stade. I misread that. Okay, so we're splitting into 3 after 3 seconds. Per lunar, we want Noida level of craziness, so this is the yarn ball doing a spiral in following the random vector that it starts with. So it's going to do this little circling path in a straight line, and then after 3 seconds, it splits into 3. And then after it splits into 3, it's going to spiral outward. And we can show one of the differences that can happen here is it's going to spiral outward first, and then it's going to spiral inward. We're going to see a very different pattern of movement out of this. So when it splits into 3, you can see that it'll start to do, like, the orbits will become weird once it splits into 3. Because if I spiral first, and then if I spiral out first and then spiral in, what we get is the ball is doing those tight little circles along the path of the spiral. But if I spiral in first and then spiral out, I have a double effect. Is it's doing that little circle, and then it's also spiraling outward from that little circle. But that the little circling pattern is trying to pull it back in tighter. Yes, there is, Lunar. A lifespan, there could be a modifier to the lifespan to reduce its lifespan when it's duplicated. Yeah, we've that's kind of one of our core gimmicks that we're working towards is stacking the movement. These are smaller building blocks than we intend to have. Like, you wouldn't have a weight 3 building block. It would be weight 3 and do this would be the core unit. But fun fact for like shaders, the entire screen except for the inventory is one rendering pass. All of the little sprites are handled by shaders on part of that rendering pass. Rendering is, even when we have like 8,000 plus objects, is practically free. Our most expensive thing right now is collision, which is the thing that I've had to tell myself is good enough for now, because I've had to circle back around onto it. These are texture shaders. I don't know which level they technically fall into, but they're not as complex as a vertex shader. There are some aspects of vertex shader that I would like to have, but the texture shader gives me some other features that I need to use instead. Here, 2 minutes before our Twitch ad begins. So in Godot, this is called a canvas item shader, essentially a 2D object shader. And effectively all of the fun is happening right here. So across the entire surface that it is drawing to for each individual sprite, we are offsetting by time. This whole logic is going to have to change at some point, but the way that we're doing the offset. These parts, so these vary. These are instanced. Which texture to use, what the entity's identifier is, and which animation on the sheet to use. This is variable per, and there is a custom data value that we pass in that tells us what these are. We get to pass in a color value for custom data. It's a bit jank. But Godot lets us pass in one color. So 4 floats that we get to mess with. This is set across all instances of the same shader. I have a number of slots big enough for my sprite sheets. This might become a problem later, but we'll see. And then similarly, what is all the animation data? How many animations are there for each of those textures? Using all of that, we can render all of those on one surface instead of having to have one surface for every different sprite. It works, and it makes our rendering, again, effectively free, which I'm pleased with. But we do have an ad starting, so I'm going to take a quick break, get up and move around, and then we're going to jump back into it and try to get our collision stuff rolling. Did that break already happen? I don't know, but I need to take a quick break. Okay. You know what? I'm just going to manually run ads from now on because the automatic ad manager is causing me pain. It's not doing what it's supposed to do, and it doing what it wants to do at bad time. But anyway. So what we want to get back into, go a bit longer, is getting into our collision handlers here. So where's our entity? There we go. Okay, so we've got our incoming interactions and our outgoing interactions. Incoming ones are, if I get an interaction message, I run it by these. Outgoing are if I run into something, if I need to interact with something, I'm going to trigger these. So we get an interaction message. And we are going to return whether we did something with it. Then a collision interaction. Where are we hiding you? A collision interaction will have a handle message that it gets handed that message. And then the individual ones need to implement this. We are going to just make you a class, and this is a virtual I've been using abstract. I need to get away from trying to use that. It's just causing me problems. Okay. So what this is doing is this is one unit of a collision. The standard units of this are going to be deals and takes damage. Lots of things will have that in their nature. So when a collision happens, go over to entity, it gets told it collided with something. It is going to send an interact event at the entity it collided with. Well, I'm sorry. It's going to... It's going to go through its collection. So, for each... collision interaction in base outgoing interaction. Outgoing interactions first. Interaction dot interact with this collision target. Okay, the base interaction gets invoked first. We might have to have an if around this to see if it does interact. But we'll see. Reach this. Interaction. Interact. This. So, every entity has something that it does by default, and it has other interactions that it will do once their conditions are met. For the most part, what this means is like after 3 seconds or something like that. But each interaction is given what is doing the colliding and what is being collided with. There is nothing stopping I collided with something impacting the one doing the colliding. So a bullet could run into something and something could happen to the bullet. This is fine. So when we collide, we do this. When we receive an interaction message for each... Oh, wait. Base incoming interaction handle message. Interaction message. In incoming interactions. If collision interaction dot handle message interaction message handled is equal to true. Bit clunky, but okay, so a bullet runs into something. That bullet is then going to say, like, okay, whatever my base interaction is, I'm going to trigger the interact on it. Then for all of my current outgoing interactions, which we're going to have to mess with here, I am going to invoke this. And then on the recipient side, those collision interactions are generally going to call interact. They are going to send messages to the entity. They don't have to. But they probably will send messages. And then that entity is going to take each of those messages and run it by its incoming interactions. Those are going to be things, again, like I can take damage or similar. If we were talking in like action RPG terms, this is where thorns could come into play. If I see a I take damage event coming in, thorns will see it and say, throw it back. The order of these interactions is important. Again, the weapon construction will be very important, because if you get events in the wrong order, you might get, well, different order of interactions will give you different events, because it's possible that a event could be handled differently each time, like the event message could be consumed. I think I need to use this. I need to use this differently. Instead of a for each, we're going to do a for loop. If it is handled, sorry, it's if it is consumed. No. We're going to need to have a property on interaction messages that is universal, and that is it has been... No, we can just handle that on the message, right? All right, there are two concepts that I'm thinking of here. There's one, if anything reacted to that message. So I pass that in. I want to know if that particular thing did anything with the message. Because it could be relevant that if I actually hit something, So the bullet strikes an object if anything was done to it. If that object acknowledged the collision. Yeah. Which means I might have to pass this by reference. I don't like doing that. But I think we might have to pass by reference. Because then we can tamper with it. But passing in by reference I don't like because it creates a sort of... It creates more uncertainty. Now, we could pass back a new message, and that message could have a handled flag on it. Like, I did something with this message. Something did something with this message. Subsequent interactions might look at that and say, I don't care about this message anymore. It's been dealt with. So let's say I have a I have a one that says I take damage and another one that says I prevent damage. If the take damage one is processed first, you take the damage. You lose 1 heart. And then the shielding one says, okay, I'm going to prevent 1 damage. They should not be asynchronous tasks. I want them to be processed in order. We want it to be kind of like the behaviors. As such, things can get weird. Yeah. And I'm passing in an object by default. I'm passing it in by reference. Could just interact with it that way. All right, let's look at interaction message. We don't have a type yet. We will. Which means we don't need the if statement here. I could just check it after the call, but we specifically are looking for a Boolean in that case. Did something touch it? I want to be careful with link statements like that. Because some link statements and combinations thereof do kill legibility very quickly. But you know what? This is one that I think we could do in that regard. At least this one we could do. Because this chunk is pretty clean. We did that in our renderer. Not physics. Physics? this is standard entity manager. I clicked the wrong thing. Mesh renderer. In process. Like the same. All right. All right. Probably say that it assumes this. Well, thanks for joining us, Stade, and thanks for swinging through Stade's Raiders. I appreciate you swinging through. So this is going to execute handle message on sequentially every element in incoming interactions. Then we should be set there. Because we have our interaction message, and we just want to know if it was handled. Any, yeah, we don't need that. It's only one thing. Right, that's all we should need. We're going to want to change this because we'll need to do it the same way that we're doing behaviors, but for the time being, these interactions are going to be finite. Like we aren't having groups of them set up in the same way. Like for behaviors. So we call the base behavior, and then if we have other behaviors, we try to open the gate, we DQ as necessary, and then if we have new behaviors after checking the gate, then we are going to take the first one in the queue and act upon it. This is the same pattern that we'll do with behaviors, is if there are any new interactions that result, from that collection, we're going to do that. How we're going to get those behaviors in there, I'm not sure. It's going to be tricky. I might have to make that a sub-element of a behavior is any interactions that come with it. But this whole thing has me thinking of how do I flatten a behavior group? Because ultimately the topmost one is the one that matters as far as like targeting and whatnot. So if we look at like behavior group here, it doesn't really have targeting. Individual behaviors do. But what I'd like to be able to do is with any behavior group that it should be able to like bubble up its elements until we have just one behavior group. Hey there, Mana. Welcome. But this gets us our start. We are working on getting our collision behavior rolling. So we need to set these up. This needs to be... We can just have this be a base collision interaction for now. So when we are instantiating the entity, when it is being constructed, these are going to be just collision interactions, which means they do nothing. And then these will be queues of collision interactions, which will contain nothing for now. Timer interactions up there above behaviors. Yeah. Let's move all of this up above with time interactions. It's up here. Why am I doing that? Because gates will ultimately control everything here. Just realized I should prime these just in case they don't get set. These base not getting set is a problem. But what this means is that it It can be. It can be. I find it engaging in various ways. Hello, Ember. Ember is deciding if she wants hugs or not. She seems to have decided that the answer is yes. It is still kind of obnoxious and adorable that she learned from Mason, the second biggest cat, that she can kind of crawl up and drape her forepaws on my shoulder so that I have to hold her and stroke her back. If she doesn't get the attention that she wants, she just kind of stands up and puts one of her hips against my face, saying like, hey, you're ignoring me. The difficulty with Mason is, if you try to lift him up, for one, he goes splay-clawed, and if you try to pivot him to put him down somewhere else, he'll start to flail. And thus, collateral damage happens. I have a lot of first aid kits. Ember is teeny tiny. She is the smallest cat. Second oldest, but smallest. And so she's less of a problem like that, but she's also the one that you want to indulge. She is a sweetheart. Super friendly, recognizes her name, very chatty. Okay, so we have those set up. So now we're going to go to our inventory. We're going to add the blobs back in, and we're going to add a row so I can fiddle with stuff. Nothing should happen when a collision occurs right now. How am I doing? I'm doing pretty well. Sleep is still a problem. But I'm managing to get the streams in, Okay. Blobs are definitely passing through bullets. They're timing out is what's going on. Which is fine. So now we need to make some new collision interactions. We are going to make the most basic set of interactions. We are going to have an outgoing collision interaction. It's called Die. Actually, this is a... It's outgoing, it is collision kill. Services, entity manager, remove entity. target entity. And then in our standard catalog, we're adding the bullet here. For the time being, this is going to be a new collision kill. We are going to need to load these interactions into the catalog properly, but... Okay, if the bullet touches something, if it collides with something, it will kill it. Sweep the world clean. Well, it's supposed to. But Entity Manager is not tagging them. Entity. Wait a minute. Hey, Vlad. Yeah, we're doing C# and Godot 4. Standard Collision Manager. Mask. All right. Oh. Oh, no. I'm not quite that mad. As another developer once said, the only reason that you build a custom game engine is if there is something that you need in your game, something that your game has to have that no game engine supplies. The example he gave was Noida, which is one of the games that is inspiring our design here, in that Noida has a wild pixel level simulation going on. Like every pixel is a material and interacts with other materials. None of the existing game engines, I think even currently, can handle that. So they had to build that at like a C level. Okay. They're looking for collisions. Get them, yarn balls. Okay. Okay, I see what's going on. We need in our entities copy. Right there. When we determine that the copy is going to happen, which means we need to make them in the catalog before we do this. Okay. Catalog, and we need catalog constants. Let's close everything here. Save that. We need our standard catalog. Time interactions, we are going to need a corresponding function for load collision interactions. Which means we also need a constructor for get on it. It's in catalog. Get time interaction. We're going to need... I don't think we can just make catalog virtual. Because there's just so much going on here. We might be able to get away with it. Because it wouldn't be bad to have a default catalog object that was just, it does nothing. Or I'm sorry, it returns like husks, or it always airs out, that kind of thing. But we'll revisit. We'll revisit. You know, instead of having there be a collision manager that is a dummy. All the geometry of a stairwell and a empty data object represent one of the ends. I mean, assuming this isn't a rhetorical question, stairwells sometimes have special logic with them in games so that you get like a snap to and climb up it. Sometimes stairwells are just a ramp that visually looks like it steps, but the actual collision surface is a smooth plane. If we're talking like Mario Brothers steps, they're just tiles. They're just bricks, and you interact with them like any other brick, you know? So you'd have to hop up them. Long story short, there's a lot of ways you could do that. A lot of game engines do have like handlers for slopes and that and the like in them, so you might be able to just like grab that kind of stuff. In our standard catalog, override, get collision interaction. Catalog. Actually have to have it specified, but we're doing it. Have to return to this to finish filling it out. We need our dictionary of strings, string to collision interaction, which will be called collision interactions. Down here, is equal to a new dictionary of collision interactions. Then we do a load collision interactions. We'll get to you in a minute. Oh no. Collision interaction is thus has to be catalogable. Collision interaction. means it needs a copy constructor. Let's check. We have another object where we're doing that with two copy equals null. So then we'll have any standard parts here, but for the time being, it do not have those parts. Then here again, see how I'm going to do. Yeah, okay. So then we need collision kill here. Our action. Let's nab that. We'll call base copy and just collision kill here. Just so. Why do we have this and it does nothing? Because it needs to be there for the catalog to recognize that that's okay. It uses this to be able to just to create a copy of what's in the catalog. There's a whole song and dance to duplicate things. Texture is an exception. Same with icons. So now we're going to say load texture. I'm going to go look for this one. Load. Kill. Nothing. Actions. String name. Kill. We go into our catalog constants. Constant string. Catalog, and this is catalog constants. And then loading the entity. Into our entity and during the copy of the entity. behavior, so timer interactions are going to have to be adjusted accordingly too. They need to be handled just like the behaviors for it to work right. Such that if there is a timer that happens after a gate, then that timer is handled only once that gate is opened and only during the lifespan of that gate, as opposed to indefinitely. So a lifespan timer is a part of the base timers. It's always happening if we want it to work. It's equal to catalog copy. There's a lot of footwork going on here. But trust me, it all makes sense once you, you're concussed enough. Incoming, and this will be base. Outgoing. Each interaction in coming interactions. In entity dot. Interactions dot enqueue. Log dot copy. Interaction, collision interaction. Hurrah! Outgoing. All right, this duplicates the rest of it there. Now it will totally work. Out. Sweep the screen. There we go. Blob touches a yarn ball, it gets wiped out. Yay! Now, this doesn't test everything that we're doing, but hey, we're making progress. We're making progress. I'm going to need to get... Eventually, we're going to find something that looks cool enough that I'm going to post another short progress update. But, in the interim... we're making progress. Actually, let's do a closing kitty check here. We can see... We're going to see all 5. Once camera 1 gets its act together. There we go. Okay. Sky's up in his cat tree. Sherbet, Mason, and... Sammy are on the bed. Sammy's the little tuxedo. Sherbet is the one on the squishmallow all curled up. ember is the kind of gray, orange, and white that is next to the kind of tan square there. Yeah, little sweethearts. Okay, what did we accomplish today? We fretted greatly over performance, but I think we've accepted that being able to get to about 20,000 things while maintaining 1 to 2 frames per second is plenty good for now. We've got our interactions started. The general logic. There's a lot we need to tweak about that, and we're going to need to figure out how to blend it in with the rest of the logic. But we'll see. Yeah. But again, thanks to the folks that rated. If you're still around, I appreciate that greatly. Thanks to all the new folks that have swung by. I hope everybody enjoyed what they saw today. If you did and would like to see more, remember to like, follow, subscribe, that sort of thing. My schedule isn't durable right now, but I'm trying to actually get plenty of streams in. So we should be seeing something a little bit more regular once I figure out what that schedule is going to be. We might try to weave some gaming in the near future. I wouldn't mind playing some more observation duty. I have fun with that. But yeah. With all of that said, I hope the rest of your day is a good one, and I will see you next time.